Hello, I'm Philip Block. I am a professor here at ETH and the director of the NCCR Digital Fabrication. It's my absolute pleasure and honor to introduce tonight's keynote, Philip Yuan Feng. His bio starts by saying that he's professor at the College of Architecture and Urban Planning at Tongji University. But I think that is kind of a very humble way to start his introduction, because I think I consider him as a very impressive and generous colleague, a true pioneer for our field, and I want to elaborate a little bit why I say that. Philip Yuan actually started, and from the base is first and foremost an important designer in China. He has a very successful and respected office, Archi-Union. And one of the things that makes him so unique is that he really took on the challenge of computational methods, digital fabrication, robotic, even on-site construction, to transfer these absolutely new paradigm-shifting and disruptive ideas into practice. And he does this in an absolutely volatile, crazy context where things always have to go so fast. And he does this with an extreme elegance, and specifically what he will also be showing in his lecture, with a clear understanding of how to adapt these technologies to be relevant in very extreme conditions, very extreme locations, understanding the local crafts, the qualities, and enhancing them through these technologies. And that is why I say that I consider him personally as a pioneer of our field, because he bridges our bubble, our academic ivory tower, by actually taking the challenge to actually, in a very sensible way, with the local partners, to transfer these technologies. I'm sure that you will appreciate all of these sensitivities in his talk tonight. And I wanted to also, so how does he do this, by the way? By absolutely rethinking how we should work. We all say that the limits is that how we do architecture, how we do construction, kind of doesn't work to really adopt innovation. So that is why Philip Yuan started his own fabrication office next to his architecture office, Fab Union, to accelerate innovation, to look carefully at what all of you presented today, and to adapt it to a context to make impact, rapid impact, in a society where many of our innovations will probably have the most impact. Last but not least, we should all also appreciate that Philip is doing a lot of effort to bring a new level of literacy and also enthusiasm, set of skills by training young architects, designers, engineers all over China through his very successful Digital Futures workshops, where basically so many ideas are tested and are being spread all over China. I wanted to make this a bit of a personal introduction, because I think Philip Yuan deserves all of this praise. So I look forward to your presentation.
Thanks a lot for the generous introduction from Philip Block. And also I'd like to thanks to Matthias and Fabio, and also including Russell. Invite me, actually last year I was here to make a lecture in NCCR. So a little pleasure for me. I would like to present totally different in the last 1 year what we're doing, and which the topic today I want to give a talk is collaborative laboratory.
Sorry, that's because I am chairing this.
That's fine. That's fine. Because I'm just talking about the collaborative laboratory. Last month, I was invited to make an individual exhibition in Berlin Gallery. And in the opening, I invited some special friends, and we have a book launch. and the book, we have a book coming out. The book title is also the same, Collaborative Laboratory. So which is a review on the last 10 years, what I'm doing in teaching, practice, and also in trying to set up a special society in China, which names Digital Futures. Actually, a lot of familiar faces here used to travel to Shanghai to teaching the workshops, and we're sharing a very good time in the last few years, including Xiao Jie from Java Code, including ICD, a lot of PhD, and including Ahim, teaching in China. So it's a special moment. I think the society, I participate to RoboArch. This is the third time. And we are growing actually with RoboArch. I think RoboArch is great and organized, and it's very happy to see so many young faces and also so many familiar faces here. I think RoboArch is something for the future. It's very important. It's coming.
We'll make the magic.
Okay, but it's fine. Let's try it. Okay. It's coming. So the lecture is actually, I'm talking about based on the book. With some people, they used to visit my studio, and also we have some talking in different kind of conference, including Antonio Picon, who wrote the preface for the book. We make a very interesting discussion in Shanghai several years ago. And also I contribute to one of his editing the AD, talking about the authorship of right now in the architecture discipline. And also AZP, Alejandro Zacabolo, and also Vladimir from New York City, Philip Urson from here, the dean from ETH, and also Neil Leach, who is collaborating with me teaching in Shanghai for more than 10 years. So I think a special discussion and in the book, and I would like to posing out some question to the digital future digital culture right now. So is there any semiology style which relate a lot to topic robotic architecture? That means is robotic architecture a kind of style which is followed by the sky to set up some architecture? So we make a lot of discussion in the last 3 to 4 years with Patrick Schumacher in Shanghai, because every year I invite him to make a talk, and we have a lot of interesting discussion on this kind of stylistic digital buildings. My response to the semiology style is quite narrative. I want to present it later through my talking. And actually, I'm quite focused on the mass production because I think architecture matters. What matters is skill matters. When we skill up in the architecture skill, everything is changed. Secondly is when we're talking about this kind of collaborative laboratory, it's more or less it's like a certain kind of social collaborative culture. What we're doing right now is kind of process. I think the process of experimentation. The meaningful things is not maybe a certain building or a certain kind of tectonics we're working, but the meaningful is a process. We try to set up something for the future. And what I want to mention in my practice, in the last several practice, is I name it the machine-human ratio. I think right now it's a time about collaboration between human being and machine. So the robotics is not a tool, not just a tool. I think robotics right now is like a partner to the designers, because right now it's a time we collaborate with the machine. We need to understand how the machine is working. We need to collaborate with them. I think why we use machine-human ratio, because in most of our practice, not totally automatically made. It's not totally by robotics. It's only part of them are fabricated by robotics. So when you're understanding of what I'm doing, I think I'm quite low-tech people in this robotic family. But I think that is, we need to still rethinking on the tools and how we can collaborate with them. This is a model actually we present in last year in Chicago. Chicago Biennale. It's a project, the name is 吃社. So how we present it in the exhibition is actually we set up a model table, and which is pieces by a small 10 kilo small robotics making like 1 week. I think nothing special because Matthias, they make this kind of things 2008. It's quite a long time ago. But I think the authorship for this kind of new technology is not stopped in 2008. It still should be going on because the most important thing for this kind of robotic making should be hidden in the design. I think design is the most important. When the people, including the curator, Mark Lee, talked to this project, he's talking about, I find nothing related to machine. It's quite moving and a quite astonishing project. It's really nothing to machine. His thing about it is everything is by hand making. So I think identity of architecture is a collaboration set up by the collaboration between human and machine. And I would like to argue that robotics, which is a global methodology, need to engage into the design process with human being. But which is more like a machine process. And the motive perception is a kind of integration of creating to find a kind of identity of emotion architecture. Emotion process is very important. So I would like to introduce the process how we designed this small building. Actually, because of budget extremely low, we find on the site, it's actually tear down a lot of buildings. We find this kind of brick is very interesting. We want to reuse this kind of bricks because the material will save the cost. But I'm thinking about how to pose in the problem to use robotics to reuse this kind of bricks. I think it is also a new creativity. So the methodology is actually, we use the sensoring, which is a feedback to the different geometry center of the brick, and position them by the center of the geometry, and put them pieces by pieces on the wall. So it's a kind of roughness compared with this kind of accuracy. So each block, every pieces of the brick is different, but the position is smoothly on the wall. It's kind of posing out as a cantilever structure, 1.8 meters. So the whole design process is quite, we name it like the performance-based design process, because it's totally based on the wind load and displacement and stress, and actually the layout of the bricks, the density of the bricks is kind of performance of the material. I think the process is hidden behind it because people don't notice this kind of performance generated process for the facade. But actually the quality is this kind of differential accuracy, preciseness, which created by the machine. So it's a collaboration process by machine and human. And next I want to talk about this is my office. In the last 10 years, we year by year construct a lot of different structure inside our office, which is a dream and description of our understanding how to make architecture as a process. I think what we are doing actually is we have a talk to Antoine Picon. He visited my office twice, and we have invited some professors to make discussion in-house and talking about the authorship recently in design. So the first part, I'm talking about the emotion, the creative of designers to understand how to collaborate with the machine. But on the other hand, it's very important. We need some tools to set up, to collaborate with us. So I think we are the first design office to have this kind of robotic yard in-house, which was constructed in 2015. And we have exhibition space, we have research center. I think everyone can touch the robotics in-house, in the design office. And also we share everything with my friends, with my students, including graduate students, PhD students. They can use all the facility here. That's also a kind of special culture we set up as kind of collaborative research between the practice and the research. So that's not just about the machine, but also we have some people working in my office. The left guy whose name is Qian Meiyou in Chinese. Qian Meiyou means, in English, means no money. It's a very funny name because he's growing up in a very poor rural district of China, and his father is so sad he's got burned and gave him a name, no money. So he's like very good carpenter. We collaborate with each other for more than 15 years. I think he teach my students and my colleagues. I think what we are learning is not from you guys, this kind of expertise in the design society, but which is very important, we're learning from the local carpenter. So they teach us a lot in the last few years, including this year we go to Venice. He's traveling 3 times to Europe this year. We participate in different exhibitions. So he's special. And also I think the office is growing. It's not a frozen moment. You design a fancy style or a fancy form. It's very normal because design office always, we don't have enough money to set up everything. So it's year by year. We set up some Ivy. They're growing year by year from 2009, 2011. And right now, I take pictures. Last year is something like this. It's a paradigm for us. It's a dream for us. It's, I think, the place we're living, we're working, and we're trying to doing a lot of experiments in this college. So what is special is in 2015, we set up a 11-meter span and 12 meters long robotic factory. I think the specialty is not the factory itself, but it's very close to the office. It's just next door to the office. So my team, we have 2 teams. Archi Union is a design team, so we have around 75 to 80 designers in-house. And the Fab Union is, right now, is a fabrication team. Mostly is some of my students after their graduation, they're working in this, around 20 people right now. So it's like a collaboration model. We try to doing some experiment. This kind of collaboration, the partnership from design and fabricators, is not the industry people is outside. I think we are not educate my student as just a consultant. I think we are teaching them they can play a leadership in the future project. They can integrate not only design, but also the fabrication. So they have the knowledge not to understand the design methodology, but also understand the fabrication methodology. So that could not be subdivided to 2 stories. So right now, the industry is growing not so fast, I think. We need to teach them. We spend a lot of time to communicate with them. We need to tell them the cost efficiency, everything we can produce. We can give them new opportunities. But I think why we can play a leader role in the industry. So we are the industry, if that's possible. So I posing the question as a designer, as an architect. And this is the environment. We're working here. I think the specialty is a process. Not everything is set up in one time. It's a different generation. The gantry robotics is off-site facility. This is different generation on-site facility we set up. And right now we have 4th generation going on. So it's by different participants in the office. I think that is the daily life with us. We are play with them. Sometimes it's just a dream. It's just a story. But sometimes it's coming very soon. We have an exhibition space and organize different kind of exhibitions every season. We have 2 exhibition spaces in Shanghai. One is on the westbound, one is in-house. And also we have Tea House. It's a mock-up. We're testing this kind of mold, the timber mold, to make this kind of custom, this kind of concrete structure. This building was constructed 10 years ago. The laboratory design process, I think I would like to name as kind of culture of testing to failure. I want to quote Bruno Latour in his book, Laboratory Life. So the ultimate objective of the research is to experiment. Through the experimentation to establish a kind of credibility. So as the analog of scientific laboratory, the design laboratory would have a rethinking on the tradition authority of architecture design. In that sense, architects, especially in the beginning of career, we need to think about how to set up the credibility by the special experimental thinking. I think we have a lot of failure, actually. I would like to introduce one of them, but Taihua will make a presentation. I hope we have a lot very good young generation. They need to have more opportunity to participate to this kind of international conference. But I'm happy they're every day testing to different kind of experiments. So take example, I would like to talk about the robotic 3D printing, actually starting from 2013. At the very beginning, we make research on this kind of slab. And several tests was done to compare the results from the uniform and the structure optimized mesh, the mesh system. The second example on the right hand, with various mesh distribution, optimize its structure behavior significantly. And we printed in 2014, this is a slab. I think the speciality is a starting point for a lot of design. We compared the result, the uniform changed to be a structure optimized mesh system, which have a very high performance than a normal slab. This is my studio. I teach 2 years ago. One of my students makes some analysis to design the furniture, a chair. The name is Keynote chair. So the learning from the Keynote to viewing his home. And we make a structure topological optimization process to make some analysis on the density, if the people sitting on it, how to reduce the material, and to set up a structure system in the chair. So this is an optimization process and the diagrams. And then we translate them to some density of the printing tools. So we set up 4 prototypes and a 4 density of the material. So the whole chairs could be translated to this kind of structure, very high structural performance chair. So this is an example. And also we're testing this kind of contour printing on the plastic. And after that, we're talking about, can we challenge to take some experimentation on this kind of plastic, could be some very high performance, structural performance material. So in 2017, we make a 3D printing, we use 3D printing machine to test a bridge. The bridge was set up by the optimization process, by this kind of different analysis, and reduce the material. So the material we print actually is the topological result of the structure. And the load for it is 5 people. So the second guy, who is the Secretary General of China Architects Society, who asked me how many people can stand on it. I told him 5. So let's try. You want to try with me? In my school. This is on the campus. So we're standing on it and take this picture. But I want to say this bridge standing here for only 42 days. So it's a great failure for my team because we make all the analysis which based on the load and distribution, but we don't recognize in the summer, Shanghai last summer extremely hot. It's like 42 degrees. So we measure it every day because after we construct it, we become very nervous. The temperature is going up. So we measure every day. So upper part of the bridge in the measurement is 72 degrees, and the bottom is 36 degrees. So the deformation on the top and bottom is quite different. So it's slowly broken by the deformation of the temperature. So we learn a lot from this collapse. And after that, we spent 4 months to take a lot of experiments on, firstly, on material, because the material we use is modified. Last one is modified PLA, and then this one transferred to modify ABS with some carbon fiber. So the melting degree raised 20 degrees, and also the performance is very good. This one we print for one of the Shanghai public space, which this pavilion standing there already more than 1 year. So it's a great testing process. And in this printing, we test very carefully about all the joints, about the tension test, and the element tension test, and also including the bending test. So the joints is very weak, so we're testing the joints should be stronger than the bar. So that's why we test if it is strong enough for the joints. After this process, I think we achieved this pavilion. We're quite satisfied with this one. This is, I think it's 12 meters to 12 meters. It's a very big scale. And after that, we participate to the competition of Venice Biennale China Pavilion. More than 30 teams participate in the competition. And what we're doing is really persuasive because we're already testing to what kind of failure and prove the new material system we can do very safely. And we should present to the team, the jury team. So the pavilion was in the Asana, the backyard, which is a very beautiful park at the end of the Asana exhibition place. That is Italian pavilion. This is Chinese pavilion. We spent 1.5 months, used 6 robotics. We name it cloud printing, parallel printing, day and night, to print the whole pavilion, which is 110 square meters, and we're unfolding it, the surface is 220 square meters. We try to persuade the shading space because it's a very long way for us now. You should travel, if you visit there, you need to spend at least 1 hour to go into dead end. So when people go into this garden, they need to take a rest, to find a place to sit down. So we try to print a space which have a very good dialogue to the context, to the trees, to the boundary of the trees, to the entrance of the Chinese interior pavilion. So it's an outdoor space. We have an interior space. So the layout for the plan is like the entrance here. When they're going outside, this is quite embracing the people to coming in. You can take a seat on the different kind of bench, and also on the 4 pavilions. You can sit inside to find a shading space. So I think the design process is not just from the robotics, it's from the design motivation. And the topic for Chinese pavilion is actually is designing the future for the countryside. So we're trying to prove we can reuse this kind of plastic material. That is a lot big problem all of the world, especially in the world. Is there any new method to reuse this kind of technology, reuse this kind of material to create something? This is a design process. Actually, it's abstract, taken up from the houses of the village and the countryside. And the whole process for the 3D printing is based on the topological optimization process. We collaborate this team in Shanghai. And the whole process is set up by a lot of tests, experimentation last 7 years, from the shared bridge, one single pavilion, implement them to prove we can do something special in the future. This is the printing process. And the other tools are the cooling. This is the weaving process. So right now we test a lot of material, and we can put outdoors, indoors, and depends on the temperature of the environment, change the material, and it could be great compression and also tension, and change the percentage of them to make different performance of the material. In the near future, try to print something special, make some special research with students. So this is the process. We need to print them pre-fabrication in Shanghai and ship it to Venice. And in Venice, it's not allowed to make foundation. Everything, including with this kind of very heavy steel panel as a foundation, and also some bench, and the sand into the bench, the foundation. And then in 4 days, plastic material. I think right now it's still okay. We have some problem, but it's fine. And as to design, I think from this perspective, you can see the boundary of the trees, and we have a very good cutting roof, which have a dialogue to the environment of the trees. So we sent some of my students to visit the site, and we took measurement of the trees and the boundary of the trees very carefully before we print the pavilion. So this is the process. And the most importantly, I think the robotics industry right now we're doing is not a single robotic machining process. It's very important to collaborate with MaxGS team. It's a structure performance-based design process. So the optimization, the simulation, and I think the subdivided, because we need to subdivide them into components and put them into the big box in the container. And we use 4 containers, the biggest size, and transport these 4 containers from Shanghai to Venice. So, which based on this kind of optimization process. So the speciality here, you can see the boundary, which is elegantly have a dialogue with the trees, and also with the entrance of the China Pavilion. You can see through the garden, and this kind of shading and shining process effects is our design. And the methodology of the structure analysis, actually at the very beginning is a flat one, but we made some node shifting, use this methodology to make the flexibility and enhance the structure on the surface. And also we make some optimization from the pre-optimization, something like this, and after the optimization, make the geometry looks better. So it's all very slow process in the design to control everything. So we have a stress diagram which will represent the forces, how they're flowing in this pavilion. Actually, what we're doing is similar to the cocoon chair I mentioned. The density of the printing process is carefully designed in 6 hierarchy, 6 components, and the layout of the density of the plastic is a pavilion. So very quick, go through to see. So in the opening, it's cloud pavilion. It's kind of floating because the people are in the opening we have some special event. I'm quite appreciate this one. And this is some other perspective when people stay inside and the sunshine, especially the kids. Okay, this is a team. Great thanks to Mark Xie. I think he is very important collaborator with us for the whole pavilion. I invited AZP at Handel who write a paper to make some comments on my project. He gave the paper title is The Politics of Making. I think it's a very interesting paper. He makes some argument on the networks of collaborative laboratory. And what is the networks? I think the impact for this kind of industry right now, I think it's not a single component of the building. It's a holistic architecture process. We need to understand what is the meaning of the architecture and the impact of this technology on the urban economics signals a potential return to the production of the city. So at least some of this kind of industry, they're quite interested in that, but their stay right now is not in this kind of automatic production process. So what we're doing actually from the next example, still this one was selected to make a special in Venice Biennale, China Pavilion, the indoors. It's a countryside project. It's a community center in Sichuan province, which is the prefect timber structure practice. And this is the whole village. The first design for this in bamboo project is 2 years ago. And last year, after this project, it's very successful. And we designed a B&B and the community industry center, and also a welcome center for the community, and the camping place, and also a public toilet, and also integrated with some other program. So it's like a system in the small village. So I try to argue that is there any possibility for the ruralism of China could be changed by the robotic industry? So which starting from one project, but they are trying to learning this technology to making something different. So that's the story I want to tell on this project. At the very beginning, this is starting from the beautiful poem. And after design, you can see this special building here, which integrate quite harmony with the environment. And this is in Venice Biennale, showing the project here. Quickly going through. So the whole presentation is about the roof system, which is, I think, 100% by the robotic fabrication industry. And the design process is very interesting for the details. And we're making the details. Every column have different heights because it's a curvature roof. And it's the simulation and the real fabrication. We use these tools to make this project. So this is a very interesting collaboration between the local people with us. So making some geometry. I think time may be not enough. I want to show some process. These are the second phases coming. New buildings. Okay. So last one, very quick for the video. It's just finished yesterday, and we'll have an exhibition here. This is center of Shanghai, Westbound. And a very famous, this is Sana. They designed a building here, an open office. And this is by Chipfield. And this corner is Archimangus Pavilion. And it was by D House. This is what we're designed, which just finished. So it's a timber structure, finished, including design, 100 days. The formal in-bamboo project, 52 days. I think that's cost-efficient, time-efficient the robotic industry can give us. So this is 3D printing cafe, 120 square meters. And this is a 40 meters span, very interesting timber structure, interior entrance. So it goes to the last video. This is a cafe. The chair and table, more than 50 chairs, and the pavilion was printed in just 5 weeks. This is last night. My team sent this. Arkim's Pavilion was in Shanghai, the very important corner, street corner of Shanghai. It was a public art project. So this is the last video. The formation for the whole building, including this is the entrance for the exhibition center, the cafe, the formation process. This pavilion was printed, including furniture, 5 weeks, and the building was constructed in 100 days, and the timber structure 27 days, including more than 900 components of the ceiling, where everything is customized by the robotics. So this is a real building coming out from the roof with the geometry and end-to-end connection. Days, 8,000 square meters. 40 to 60 meter span, 29 days for the entrance. So this is a lightweight aluminum band structure. This is timber structure. So the optimization process is from column to take away the column, make a special arch to support the whole system. So the structure performance-based design process. Important and everything in 27 days, how to solve the tolerance from the details. So we do not waste any components. So every piece is precisely colored. Medium is a kind of tropical structure system. We have a special details to control the tolerance and the strength. Totally 923 components, 14 different kind of joints, and the milling process will use 6 robotics milling 1 month and a half in the factory for all the details. It's not a very complicated process or very sexy process, it's very normal, but it saves a lot of the weight of material because the very width team was subdivided in 2 parts. 15 centimeters for each pieces. It's extremely light. Okay, thank you. Thank you to all of you.